याद रख तू कौन है, पर्वत को चीर फाड़ेगा तू। पंख नहीं दिखते तेरे, पर भर ले तू ऐसी उड़ान। उड़ जा नन्हे पंछी कर दे सब परिंदों को तू हैरान। कोशिशों से मिलती कामयाबी, कामयाबी का तू हकदार है। रास्तों की खाके ठोकरें, जीतने के लिए तू अब तैयार है। वो रुकना कैसा, डरना कैसा। बात नहीं कोई अब डरने की, कर ले जिद आगे बढ़ने की। बात नहीं कोई अब डरने की, कर ले जिद आगे बढ़ने की।
Hello and good evening, everyone. I am your host Manpreet. Welcome to the fourth season of IST Practicals by Internshala Trainings. IST Practicals is a series of 3 online masterclasses delivered by industry experts. These 45-minute sessions are all about teaching students important concepts, softwares, and tools. Every IST Practical is an opportunity to experience the power of practical learning. The topic of today's session is SolidWorks, and our teacher today is Mohsina Zafar. Mohsina holds a master's degree in Mechatronics and Control engineering. She is enthusiastic about product design and has been using SolidWorks as a main design tool for over 6 years. Today, she provides technical support and design services to thousands of SolidWorks users around the world. Mohsina believes in learning at all ages and is eager to spread her knowledge related to SolidWorks. I hope you will enjoy this webinar with us. We have a very special gift for you at the end, so stay tuned for that. Let's dive straight into SolidWorks now and welcome Mohsina.
Thank you, Manpreet, for introducing me. So, my name is Mohsina Zafar, and today we will be discussing how to bring your ideas to life using SolidWorks. So, before starting the webinar, I'll ask you a question. What does CAD stand for? As this would be an interactive session, you can you type your comments in the comment section of the chat so that I can know how many of you know what this term stands for. Once again, if you are being confused on how to interact, there in the YouTube chat option, you can type in your comments. Okay, so many people are saying that it stands for computer-aided design. Yes, that's right, which means that so many of people know what it stands for. So the next question is, have you used SolidWorks before? If you're a user of SolidWorks, you can tell us in the comment section. Okay, so there are a few yes and so many no's. But even if you're familiar with it or not, we have something in this webinar so that after this, you will be starting your SolidWorks journey and enjoying the process. So stay tuned and let's dive into this training. So we'll be learning how to bring your ideas to life using SolidWorks. SolidWorks is a tool of 3D CAD design which helps you to create objects, everyday life objects. They can be simple as well as complex. You can project your ideas into a virtual and functional platform using this tool. How we'll go about this webinar is, first we will discuss the importance of engineering drawing. Then we will move on to part modeling. Along the way, we will be navigating the SolidWorks interface, and then we will be creating engineering drawing. Now let's see what are the possibilities of SolidWorks. These are all the objects that have been created using SolidWorks as the design tool. You can see that simple objects like scissors and glass can be created, and complex objects like aeroplanes as well as turbines can also be created using SolidWorks software. So before we start modeling something, it's important to discuss engineering drawing. So imagine watching a movie where you can only read the subtitles and there's someone who is telling you what is going on in the movie. But it would be really difficult to comprehend what's going on. So same is the case if someone tries to tell you what is in their mind, what they want to make or a product, and they try to tell you about it, but without an engineering drawing. So it would be really difficult to understand what they exactly want and what their requirements are. So engineering drawing is of utmost importance. This is why we use them. Engineering drawing, as shown here, is a sketch or a 2D view of a 3D object. It shows how the part looks like, what its size is, and how it would fit together. You might create an engineering drawing to convey your requirements to a vendor, to get feedback from the client, to market your product, or hand it over for manufacturing. Here, a client asked us to create a camera, and he created a rough sketch for us to see it. But as you can see that this is a rough sketch, a haphazardly drawn sketch, which shows us the requirements but is not a neat one. So we can understand the requirements from here. To make it clearer, here is something that we created. From this, you can easily see what is trying to be created. This is the camera. You can download the drawing from the chat section. Manpreet, can you please insert the image into the chat box so that the audience can refer to it? Thank you so much. So here is the camera that we are going to model today. Remember that this is the engineering drawing, as this is a 2D view, and we will be moving on to create the part, the model, which would be 3D, and we'll be building upon this engineering drawing. Now let's move on to a question. Here's a question for you all. Who can benefit from engineering drawing? The options are designers, engineers, manufacturers, and all of the above. Okay, so I can see so many D's here. Let's select it. And that's right, that's the correct answer. So many people involved in the design manufacturing process can benefit from it. Now from this engineering drawing, let's move on to SolidWorks. Here we will start a new part, go to File, New. And here you can see three SolidWorks environments, namely Part, Assembly, and Drawing. Part is when you want to create a single part or a model. Assembly is when there are different parts and you need to link them together. And drawing, finally, is the engineering drawing that we will be coming back at the end. So click on Part, click OK. Here is the SolidWorks interface. In the middle here, you can see a blank space. This is called Canvas. And here on the left, we have something called Design Tree, Feature Manager Design Tree. In this design tree, you can see that there is front, top, and right plane. These are the standard planes from which we can create the part. For the camera, for creating the camera, let's click on the front plane. Go to this tab, Sketch tab, and click on sketch. Now you can create the sketch. You can see that these are the tabs in the command manager. This entire ribbon is called the command manager and it has different tabs. Each tab has its own set of tools, and you can select it to gradually make the object. Let's move on to the drawing. Here is the camera and we will be starting with the base shape, which is the rectangle. So let's have it here. Go to it and you can refer to the drawing which has been provided in the chat box. This is the tool, which is center rectangle tool, and we will start creating the sketch. This right in the middle is the origin, and make sure to create your sketches from the origin. We click it and here we have created the rectangle. Now you can see that the rectangle is not fixed. So we need to insert the dimensions, and for that we will use the smart dimension tool. Before that, let's check out here at the bottom. This says IPS. When you hover over it, you can see that the unit system is inch, pound, second. Referring again to it at the bottom right corner, you can see that the unit system says inch, pound, and second. However, the drawing that has been provided is in centimeter, gram, and seconds. Before adding the dimensions, let's select this measurement system. Go to sketch and click on this edit sketch. We have opened it. Now go to the smart dimension and add the dimensions that have been provided. .5, click OK. And now our sketch has been created. Let's exit the sketch. Now you can see that this is 2D. However, we said that SOLIDWORKS is used to create 3D objects. How to push forward this sketch into a 3D object? For that, we will go to this Features tab, go to Extrude Boss, select the sketch, and you can see that the sketch has been pushed forward. For this, we will add the dimension of 1.2 and click OK. A 3D object has been created. Now let's go to the drawing again. The next step would be to create this circular lens part. Let's go back, click on this face. The first sketch that we created was created on front plane, but as we go on and start extruding things, every flat surface or a face becomes a plane and we can create another sketch on it. So click on it, and here is from the pop-up, you can click on sketch, and from the tools, you can select the circle. Now let's count how many circles there are. There are 5 circles. So let's start creating them. And click OK. Now you can see that the 5 circles do not share the same centers. To make them share the center, press Ctrl and click on each of the circles. From the left, you can see that relations can be added. Click concentric relation and click OK. Now all of these share the same center. Now let's start adding dimensions. From the same drawing, I will be adding these dimensions. Five, 4, the next is 3.4. This one would be 3.2. The last one would be 2.1. So now that it's done, I had told you in the previous sketch that start the sketch from origin. But you might have seen that this sketch does not need to be created on origin. It needs to be created from somewhere else. So what should we do? You can also notice that this sketch is blue in color, which means that it is underdefined. At the bottom tab here, I'm hovering over it. You can see the status of the sketch says underdefined, which means that the sketch is not defined. If I try to move it around, the circles can move anywhere. But this is not what we want. We want them to stay at their place. It is important to have the part defined because if the part remains underdefined and we go on to connect parts together and create an assembly, changing, modifying the sketches, changing the dimensions after creating the parts will affect the complete part and can also make the assembly to explode. So that is not what we need because all our effort would be wasted. So to make this defined, fully defined, what we need to do is add some dimensions or relations to make it fully defined. So starting the sketch from the origin is not necessary, but linking it to origin is necessary. So how we will link it to origin? Let's go to Smart Dimension, click on these 2 points and add the distance between these two, which would be 1.4. Now that it is done, the sketch is still blue in color. Press Ctrl, click on these 2 points, and at the left you can see that horizontal is shown. When you click OK, these 2 points are now horizontally aligned. You can notice that the sketch turned from blue to black, and the status at the bottom has changed to fully defined. And this is what we want for each of our sketches. Let's exit the sketch as well. Go back to this model, and for this lens part, you can look at the top view and see that each of these has a different protrusion. To do that, let's go to Extrude Boss, and for this, you can see that at the bottom is the selected contours option. We will go to this option and select a region. When you hover over a region, it is colored. So let's go to this region and provide the extrusion, which would be 0.2. You can see that the first extrusion has been made and the sketch is nowhere to be seen. To use the same sketch to create other extrusions, expand this extrude, click on the sketch, and you have the sketch back. Go to Extrude Boss again, click on this inner region, add the dimension of 0.4, and it will be extruded. Again, select the sketch, go to Extrude, add the value, select the region, and click OK. And for the last time, we will be doing the same thing. Select this, enter the value, and click OK. Here, our lens part has been created. Now let's move on to this top sketches. You can see from the top view that they are cut inwards. These two sketches are cut inwards. For that, let's click on this, go to Sketch, and start creating these sketches. Let's create a circle, and then there's a slot. We'll go to the straight slot, and create this. Again, adding dimensions to it, go to Smart Dimension. Sorry, it would be double click on the dimension to edit it. It would be 1.6. 0.2 and 0.3. Again, these sketches are blue in color and the status shows underdefined. Let's add other dimensions. The distance between the centers is 1.25. Again, linking it to origin. This would be 0.45. And adding this dimension, it will be 0.6. The sketch has been fully defined. Go to features, and you, as extruded boss projects the sketch outwards, to cut it, we will be using extruded cut option. And for the value, we will give 0.1. Click OK. And you can see that a slot has been created. So next, let's create the top button, which can be seen from here, but here it is on the top. Click on this face, go to Sketch tab, Sketch, and we will be creating a straight slot again. Go to Smart Dimensions and add all the necessary dimensions. You can see that we have added the dimensions, but still we can move this around. And you can see that we cannot move it horizontally, but vertically it can be moved. To restrict this motion, let's create a center line from midpoint of this to this. Press Escape, click on the midpoint, press Ctrl, select the center line, and add the coincident relation. Click OK, and you can see that the sketch has turned black, and again it is fully defined. Go to Features, Extruded Boss, and insert 0.05 centimeters. Click OK, and this has been created. One last feature that has to be used, you can see that from the top, this camera has a sleeker look. It is rounded. However, this has sharp edges. So to round the edges, go to this fillet feature, select these edges and these two edges here. And here, add 0.6 centimeters. So this has been created. Let's move on to a question here. Okay, so the question is it necessary to fully define a sketch? Again, you can type in the answers in the comment section. Is it necessary to fully define a sketch? Okay, so A option, yes, we have repeatedly talked about it, that it is of utmost importance to fully define a sketch. That's right. Okay, so now let's move on to some other important things. You can see that the view of the model can be changed. To do this, you can right click on the canvas, and here are the few options. One is rotate view. If you click on it and drag the mouse button, you can see that the part can be rotated. Click on it again, and here will be pan. From this feature, you can see that the model can be moved around. Selecting another one which says roll view. From this, the model can roll about an axis. So let's go to select again. And we will talk here about other viewing options of the model. This toolbar here on the canvas is called the heads up view toolbar. Let's discuss what these tools do. The first one is zoom to fit. This will fit the entire model on the canvas so that it can be seen properly. Let's click on it and you can see that it has been zoomed in. But let's see that I zoom into some place by scrolling the mouse button and my model has vanished. I want to bring it back, but I don't know where on the screen it might be present. So to get it back, click on zoom to fit and the model will be back. Again, if I zoom into the model and again I want to see the entire of it, click on it and here it would be. The second tool is zoom to area. If you want to zoom into an area, you can create a window and this tool would zoom into it. Click on this to get it back. Another interesting option is here, view orientation. When you press it, you can see that standard views can be seen here, front, right, back, top, and thumbnails showing how they would look like are also there. A 3D view shown is isometric, dimetric, and trimetric, and let's create an isometric view. And here is the model in 3D. Now let's discuss this tool which says section view. It is also an important tool which shows the section view of the model. You can drag it and you can see that you can see cross sections of the model. You can also select the plane for it, go to top plane, and here it will show the cross sectional view along the top plane. Going to right plane and similarly you can see this. Okay, so another option here is the display style. The display style selected here is shaded with edges. There can be hidden lines removed and with hidden lines. These are different display styles for the models. Let's get back to shaded with edges. One other interesting thing that needs to be discussed here is let's right click on this and there will be two icons, dynamic reference visualization parent and dynamic reference visualization child. Let's click on parent. What this tool does is it shows link between features in the feature manager design tree. As I hover over Boss Extrude 1, it shows that it is created on origin and is linked to front plane. If I hover over Boss Extrude 3, it shows its linkage with Sketch 2, Boss Extrude 1, and Origin. Similarly, wherever you go, Fillet 1 is created on Boss Extrude 1, as you can see from here. Now let's select Dynamic Reference Visualization Child. Now you can see that as I hover over Boss Extrude 1, it shows the blue arrows show the parent references on which Boss Extrude 1 is created. And the purple arrows show the child references, the features which are created on Boss Extrude 1. So this is a really important feature, dynamic reference visualization, and that is because it will help you understand which feature is linked to which one, so that modifying or deleting an item, a sketch, or a feature tells beforehand how the other features will be affected. So as you can see that all the features are created on Boss Extrude 1. What happens if we try to delete Boss Extrude 1? Let's right click on it, delete it, and click on yes. And you can see that warning has been created. Let's ignore the warning. Another warning has been created, and you can see that there are so many warnings and errors that have been popped up. And the model also is in red, which shows that it is not correct. So let's press Ctrl Z and we are back to the model. So you can see that how dynamic reference visualization has helped us understand how deleting the feature would be affecting the things uh, depending on it. Now let's save. Let's save it with the name camera and head over to the quiz. There's another question here. I want you all to be interacting using the chat. So this is the question, which means what does dynamic reference visualization show? So the options are change in dimensions, link between dimensions, link between features, or all of the above. Okay, so there are mixed reviews, something that it is all of the above, and something that it is linked between features. The correct answer is link between features. And why is that so? The change in dimensions is not reflected. The connectivity or link between dimensions, how one dimension would affect the other, is not considered in this one. However, the link between dimensions, how they are connected, how they are dependent on one another, that is what dynamic reference visualization shows. Let's submit it. And yes, that's the correct answer. So now let's move on to the next step. Here is where we had created the camera. Go to file, and now we will be making drawing from the part. Click on this. There are different sheet formats in landscape and portrait formats. You can click on any one of these according to your requirements and click OK. Now on the right in the view palette, you can see that there are different standard orthogonal views. Orthogonal means that they are 90 degrees to each other. When you rotate the part at 90 degrees, the other view is shown. So this is the front view, top view, and right view. We can add it in the drawing by clicking and dragging it into the drawing. I place it here. Now as I move left to right or anywhere, you can see that different views are created. So the views that I need here, the top view, then we'll go to side view. And if you move diagonally, you will see the 3D isometric view. Now that we have created it, let's click on OK. Move this view over here. And in the left property manager of the view, you can see the display style. And you can notice that this is what we had covered before. So what we want is, we want to make this shaded with edges, and let's make it high quality. Click OK. Now let's go to model items. Go to click entire model. Select this option, import items, and click OK. You can see that the dimensions have been added into this drawing. But these are not the dimensions that we had added. So at the bottom right corner, make sure that the same unit system is selected as the one in which we created the model. So it would be CGS, and the drawing has been updated. So now it looks all jumbled up and is not clear at all. I cannot understand the dimensions, and the client or vendor would not understand it as well. So for some housekeeping, let's create a window around it. An icon will appear, hover over it, and here is the tool Auto Arrange Dimensions. Click on it, and you can see that all of a sudden the drawing looks a lot better. A little more, making it neat, just move them around. And here is our drawing. So one thing that we need to discuss here, let's go on to the camera and let's edit our dimension. Go to here, sketch, edit the sketch, double click on the dimension, which is 9.5, and let's make it 10.5 and click on OK. Now move on to this tab, and you can see that this dimension 9.5 centimeters has been changed to 10.5. So another thing, you can see that there's a block here which says the drawing is camera. If this is something that we want to share with our client, this shows information regarding the model. For this, right click on the drawing, go to edit sheet format, and here the title block, this section which is called the title block, gets editable. We can zoom into it, and let's move this camera to the title. This shows the weight, the scale of the sketch, which shows that this drawing is of the same scale as the model that we had created. And for the drawing number, let's click on note and add a note here. This is the drawing number, and this shows revisions, how many revisions have been performed on the part. So drawn by, and all these comments, the materials, everything you can add here so that it becomes more understandable. Right click and click edit sheet, press F, and it would be back. Now that it's done, we have another question for you. So the question is, how will the changes in the model be updated in the corresponding drawing? The options are automatically, manually, by restarting SOLIDWORKS, or none of the above. Again, you can type in the comment section. Okay, so many A's here, and that's right. As we had covered, it automatically, the dimension had changed in the drawing. So all of this has been covered. So let's have a recap of what we learned today. We understood the importance of engineering drawing. Then we created a camera, we modeled it, and then along the way, we navigated SOLIDWORKS interface, in which we learned how to have different views, how to view the model in different aspects from different perspectives, and how to align the views according to our own requirements. And another feature that we talked about was dynamic reference visualization. And after that, we created the engineering drawing and added all the dimensions so that it could be readable and understandable. So by creating the drawing, we reinforced the importance of engineering drawing and make you understand that it is of utmost importance, and the uh, so many engineering disciplines have this as the main subject, and to so that students can understand, create, and read the engineering drawings properly. So that's it about the webinar. Over to Manpreet.
Thanks, Mohsina, for the amazing webinar. I'm sure we all got to learn a lot of new things today. So now I think we can open the floor to our audience for the questions. But before you start taking their questions in the chat, I wanted to ask you something.
Sure.
So my question to you is that as somebody who is eagerly interested in learning more and growing in this domain, what is the right path for me?
Okay, so as a beginner, it's really important to learn the basics and then move on to upskilling. So, for the beginners, for the students who are engineers, for technicians, those students can learn SolidWorks as well as engineering drawing in their schools, universities as well. Other than that, there are so many resources online on YouTube. If you need a structured and comprehensive course regarding this, then Internshala offers two courses regarding SolidWorks. We have a basic course for beginners, which takes you from beginner level to creating complex objects, and from beginner to advanced level, which takes you to creating more complex objects and optimize the design and modeling process along while making those complex objects. So those I would highly recommend that you go through those two online courses, as they are really comprehensive and dive deep into SolidWorks domain.
That's right. And for all the keen learners here today, Internshala Trainings is offering a special 10% discount on the SolidWorks training and all our other 70 plus trainings. All you have to do is click on the link in the description and use the code practicals10 to enroll now. We can now open the floor to our audience for questions. So, Mosina, if you could take their questions up, please.
Okay, so now that the questions are pouring in, there are a few questions. Let me start answering those. So someone asked the installation link. SolidWorks can be installed for free. It is a trial version. You can download the trial version from the official website. And for those asking if it's a commercial software, yes, it can be used commercially, but the commercial software is has to be bought. So you can also download that one from SolidWorks official website. So the trial version is also there. You can use the trial version for a month or two, and that's it. How you can install it. So the question, another question, interesting one, says why is SolidWorks expensive? From the possibility slide, we had learned what SolidWorks can achieve. So SolidWorks is usually used in marketplaces by huge companies which have to build uh, complex objects. So for that purpose, SolidWorks is expensive because one, it is a commercial software. Two, it has different upgrades as well in the uh, software, some minor upgrades, and that is why, being a commercial software and as it is used in huge objects, creating um, objects on a massive scale, that is why it is expensive. No, I think that there's a confusion. SolidWorks is not that expensive. The student version is there. You can download the student version, which is very pocket friendly, and it is not as expensive as you have mentioned here. The student version, you can get the student version. Which purpose to use the SolidWorks? So SolidWorks is used when you have to create something using dimensions and relations. And that is mostly used in engineering disciplines when you are creating objects of, when you're creating machine parts and objects that need to be created using dimensions.
All right,
Okay,
I
let's
think
move to the
that
question.
would be all, Musina.
Okay, okay, sure, sure.
So thank you so much everyone for joining, and thanks Musina for the awesome session. Don't forget to like this video and share it with your friends. Do subscribe to our YouTube channel and press that bell icon to never miss another update regarding our upcoming events. You can also join our Telegram channel. The link is in the description. So see you guys soon. Take care. Bye.